network software engineer at 191 IONOS, where he's been working on improving and supporting the growth of Infiniband-based cloud for the past 3 to 5 years. Before transitioning to the public cloud, he started in telecom industry, which users are known to have high reliability expectations. So he's got some experience in the reliability part of the telecom industry. And apart from OFA, he also participates in OCP, RIPE, and SDN and FE related events and conferences. So Vladimir, please welcome to OFA again. And let's get started. You have the stage now.
Perfect. Thanks, everyone. And thanks, Divya. So my colleagues have already presented here 3 years ago on the another iteration of Ethernet over Infiniband, and you probably also know us from the RDMA network block device, which is today is basically available in the upstream, and there are daily patches on the mailing list. So for me, I would consider still myself a little bit of a novice as it comes to Infiniband. 3.5 years of experience there. I wanted to share my findings here. I would say it's a simpler presentation of what you would normally see in the Infiniband users group, which existed some time ago. So next slide, please. Today we are going to talk in general about the reliability and knowledge base for Infiniband and the failures and mitigation that are available on all levels of the Infiniband architecture. But the focus of it, I would say, is on the link layer and the subnet management, as it's a critical component of the infrastructure. Next slide, please. So for reliability and knowledge base, I would say I have to I cannot help but do a comparison here, coming from the Ethernet world to Infiniband world. The first thing that stands out is the ecosystem variety, and normally you would get all kinds of guides, solutions, training and certification programs on the technology. In Infiniband, what I see is there's a great quality program reference manuals, architecture specifications, and some articles that are already available in the mailing list. All that in general helps, but I would say it's a little different. So this the ecosystem is really different here. One other thing that's worth mentioning is not every Infiniband user is downtime intolerant. So cloud, finance, and some part of the HPC fabrics, from what I saw, do not tolerate downtime. Finally, as we go into the communities for Ethernet, there's so many communities, smaller communities operating user groups that address all the small details that go all the way from the protocols down to the implementations and user experience with a specific technology. I would say we're on the way there. IB becomes a commodity, and as I see personally, there are more and more POC setups, and people just getting into the IB as it's now widely available. I would also mention one more thing here: the books. Actually, that's something that I would like to see more in the Infiniband world and in general in all of the fabrics. Something that's written, something that's done from engineers and to engineers, and that helps us to understand what were the trade-offs in the specific hardware or software product. And in general, this knowledge helps us to understand how how to work with a specific product, what to push and what not to push, and that knowledge I would greatly welcome in the IB world. Finally, the OFA presentations greatly help. As I mentioned, the IBAC level presentations were a great help, and I think, yes, with this this could be one of the presentations that could help future users as well. Next slide, please. As we go to the failures and mitigation, I would like to repeat here that basically I think there's definitely a survivorship bias. There's a collection of assumptions, and there's an Ethernet influence overall. These factors have to be considered, and I try to really think about them in this presentation here as well. So if we go to the layer 1, I would say it's not a major cause of concern. It's not the biggest cause of outages there. So the DEX, the optical are tested well. The failure rates are low. Counters are basically provide us with the working monitoring, and the only two things I would like to mention here is that the chassis could be a cause of concern. So it is best to follow the manufacturer's recommendations, and the best practice is to stay within one generation within the chassis. Additionally, as we have faced this while expanding all over the world, it takes time for the co-location personnel to understand the specifics while working with the IB cabling and IB in general. Next slide, please. So before we go into the layer 2 of Infiniband, I would like to reiterate a little bit on the modern Ethernet fabrics and see what things are there in common and what things are different, because today I would say modern Ethernet fabrics are pretty reliable, and there are things that we can learn from there. So on the slide here, you see an example of a modern Ethernet fabric. This is entirely layer 3. So every host that you see here is basically a router, and you see the normal flow topology on this slide. So next slide, please. Sorry, I think there was a more updated version of the presentation, but it's not a problem. I will just add more points as we go. So in modern data center designs, there's really no layer 2 multicast. There's dynamic routing and point-to-point links. ECMP, equal cost multipath, is in use. Additional factors that help to keep it more stable are that basically there's no auto negotiation on those links. There are no chassis dual supervisors or kernel sync mechanisms in the modern equipment, and complexity is pushed up the stack into overlays. So no multicast, no layer 2 information. Broadcast domains are minimal. They stay on the point-to-point links, and all those factors combined, especially with the dynamic routing, that handshake and keep alive based fabric. So there will be no forwarding of traffic unless yes, there's a agreement between the switches that there's everything fine on the routing side, and only then the traffic would be forwarded. If there's no consensus, if there's no handshake, the traffic would be dropped fairly early on and will not affect the fabric in any way. So next slide, please. As we go into the IB fabrics here in layer 2, the constant growth really means more variety, means adding more and more racks into a live fabric, and basically we have to deal with the firmware version variety, and we have to establish the hardware lifecycle process and watch this process very closely. And one of the really important things here is the switch firmware. It could be really catastrophic for the fabric to have a bad switch firmware version in it. It could mean a propagation of errors in the fabric, so link flaps or longer link up times. Usually we deal with this by using the managed switches with local flashing, and with the automation with ZTP, we are getting the switches ready when they are installed and they are not affecting the fabric in any way. The call to action here would be to have the switch dev or Sonic running on those switches, because as for us, we're already Linux heavy. We build and run gateway systems. We use Prometheus, InfluxDB, so whatever you give us in sysfs or TempFS, we would expose those counters to the monitoring systems, and we would be fine there. So as of now, unfortunately, it's a system that still needs to be disaggregated. Also, obviously, the externally managed switches could help there with the. That would mean the updates, the firmware updates have to be done before the installation into the fabric, and that may lead to scale issues. Finally, for the firmware, I would say it is best to stay within a generation, max 2 generations in a cluster. Negotiation errors could be the smallest penalty, but apart from that, there could be also features could be different, obviously, between the generations. So next slide, please. Around 70% of the incidents, they do come from changes, and I think we see that in the infrastructure. IBs, we all know, is a centrally managed fabric, and it is normal to run a few subnet managers there. However, we've seen some events where there was a cascading failure of the subnet managers in the fabric. I think that particular case that you see here, the log exempt, actually came from the loop in the fabric, but in the end, we all need to understand that the blast radius for Infiniband it could equal up to the entire fabric there. Next slide, please. There obviously are some mechanisms, so git lit, SADB sync, that help. So there are more advanced features. They however, they, I think, add more complexity but do not guarantee availability. One other thing that is worth mentioning is the CPU resources that are limited on the switches. An example of CPU intensive operation could be multicast joins or leaves that are processed, and I think it's industry best practice to use the specialized hosts for the subnet managers. Finally, one very important finding for us is basically to ensure that the unhealthy nodes are removed from the fabric. It's probably related to the stack firmware. So whenever the driver is not reset, so whenever a system has experienced some under voltage or crashed, and yes, the driver was not reloaded, ended in kdump or whatever. So there are many situations where this could happen, but the symptoms are that there's a flooded fabric and the SM cannot reach the remote HCs or switches. So the management diagrams will not reach those far hosts, and that's basically mitigated with the enabling heavy sweeps functionality in the OpenSM and also enabling the unicast cache. Next slide, please. On this slide here, you see a well-known example of the dual fabric approach. So from the IBTA release 1.4, page 1190, on the left side, you see it here, and on the right side, you could see an example of the dual fabric approach of very small existing design, which we use in the fabrics, with the hypervisor and storage nodes down and to the right. Next slide, please. So yes, it's great that this dual fabric approach is documented. However, I would say there is a major detail that is not mentioned there, and that is that the fabrics by default they're not secured. So if a cable is connected to, if a cable links both fabrics, obviously there is a reassignment of lids and recreation of multicast groups, and RDMA connection go out the window at that point, and that's something that we want to avoid. And yes, obviously the SM and M key with a higher protection level is a valid countermeasure for that. So dual fabrics, it's not a waste of resources. It's very good aligned with the equal cost multipath for network and storage traffic, and also allows blazingly fast rollouts, and as well zero traffic loss, as we can completely drain the fabric from the traffic and then do any dangerous operations or any troubleshooting on it. And one other thing that's worth mentioning, as we are still on the layer 2, the 3-stage or 5-stage flow topologies are the most tested, well-known, and feature-rich topologies. Don't build rings. I would say the CLO 3 is something that most of the people who are trying to build the new fabrics can live with. So next slide, please. Layer 3 and Layer 4 are largely out of scope. For Layer 4, I would only say that due to the recent adjustments on the on UD mode, basically it was rewritten for MLX5 and for IPYB because of the multi-queue improvements and other stuff. The real MTU, the real IB MTU is now the max available MTU. However, the RC was not super helpful for IP over IB. Next slide, please. So we are on the upper layer protocols layer, and here it's primarily about IPYB. We use that heavily. It's well-known protocol based on the hardware replicated multicast groups. These groups will be reassigned, recreated on start of or failover of the subnet manager, and that leads to at least 40 milliseconds outage for a very small fabric. And generally, this is done basically in a for loop, and this is impactful for the fabric. So I see there's a possibility to improve that in the OpenSM code. Failures for on IPYB are generally hard to detect, so we try to deal with this using the routing protocols all the way from the gateway systems down to the hypervisor systems, and generally that's been working fine today. There are supplementary mechanisms, bidirectional forwarding detection, that's basically UDP streams that allow for very fast convergence and failure detection on the path. So IP route 2 will not help much while dealing with the IP over IB issues. The IB dump would be the main tool for dealing with the IP over IB, looking at exactly what the issue is with the traffic. Next slide, please. And yes, before we go to the content here, please think of any questions that you might have at this point. We'll be finishing soon. Just
there are a
giving
couple
you...
of questions here. I can wait till the end since you're finishing off soon.
Yeah, I think I can answer slightly later
Okay.
on all these questions. Thank you. So continue with IPYB. We feel it's like a little small test base. We ran into quite some corner cases there, and especially for IPv6. So we already submitted the patches for that. An example I could tell, an example that's related to IPYB. There was an IPYB bug which was sitting there quietly. With the restart of the subnet manager, there was a key removal event, and dozens of systems were actually hung on mutex after the P keys were removed from the fabric. And this comes as another reminder of the shared fate or no redundancy for the software components like the driver or ULP module itself, and that's mitigated with testing. So I think that was it. So I think a simple presentation. Thank you for being here, and I will now I'll now be able to answer all your questions. So first one is from Mark. Which generations of Infiniband are you experienced based on EDR and HDR? And the answer to that question is, I think we started in 2009. We started with DDR back then, and yeah, we are now at EDR in the infrastructure, looking at the HDR already. So all the all the new data centers are built on EDR. And the second one, are you using a stock distro or based on a vendor proprietary stack like MOFET? So we are using some parts of the MOFET in the infrastructure, but we are contributing heavily to the upstream, and we are using some of the upstream components of the RDMA core in the infrastructure. And I think we're on the right track there. So I would say there's a great deal of stability that comes from the upstream RDMA core, and I think that's what I learned for the past years. Well, obviously MOFET has great features there as well. Yep. Thanks for your questions, Mark. Are there any other questions or thoughts that you would like to share?
Other questions for Mark?
This is Mark again. Sorry for asking all the questions. So some of the challenges of moving forward to a new InfiniBand data rate, new InfiniBand product generation, is you get a lot of challenges in the ecosystem, bringing up the links, getting stable cables, getting copper cables working at 2 meters, 3 meters. Did you experience that when moving to a new InfiniBand data rate, or are you running somewhat behind the curve and all of those ecosystem issues are solved before you start deploying?
Very good question, I think. So for InfiniBand, I would say we were a little late to the party with the EDR, so I think we missed most of the issues with the EDR, but we definitely had a mouthful of issues with the FDR, FDR10, and yes, QDR. Definitely. So, and especially there was a lot of complexity on the chassis side. So all the different chassis vendors, and yes, definitely that's where their recommendation of checking the, especially for the chassis part, signal integrity. That's where that comes from.
And do you feel like you have good tools and good monitoring to find those link level problems when they occur in large clusters, and narrow down on the specific link or port that has the issue and isolate and replace it?
Yeah, absolutely. With the
Okay.
with the already existing instruments, I think you could also take a look at our internally developed FabricMon. This provides yet another alternative, basically, of exporting the counters and to the InfluxDB, where that could scale well, and where you could get the fast reaction on any query to a pretty massive infrastructure.
That's great. Thank you.
You're welcome.
Other questions for Vladimir? All right. Thank you, Vladimir.